find an integrating factor, then solve the differential equation. This differential equation is in the form m is a function of xy, m dx, plus n as a function of xy, dy equals 0. And we know that if the partial derivative of m with respect to y is equal to partial derivative of n with respect to x, if they are equal in some rectangle or in some connected space, that implies the equation is exact in that space. Okay, let's see. So here m as a function of xy is, so we don't even have to write this one. I would just say this is m, this is n, or you can be more precise saying xy and xy. Then m y, the partial derivative of m with respect to y. So with respect to y means x behaves like constant, so 3x is constant, and derivative of y is 1, so this is 3x squared plus 2x behaves like constant, derivative of y is 1, so this is 2x plus derivative of y cube, this is with respect to y, so 3y squared. Let's find the partial derivative of n with respect to x. With respect to x, derivative of x square is 2x plus derivative of y square is 0, because y square behaves like constant, and clearly these two are not same. These are not the same, not equal, so this differential equation is not exact. That's why the question is asking us to find an integrating factor. Okay, we want to find an integrating factor so that this becomes exact, and then we solve this ODE. ODE means ordinary differential equation. Okay, and we saw in class we need to find two things. One is my minus nx over n, nx over n. If this is a function of x alone, if this is function of x alone, then e raised to integral of this with respect to x will be the integrating factor. If this is not a function of x alone, then we do other way around, nx minus my over m. Okay, this should match. If this is a function of y alone, function of y alone, then e raised to integral of this with respect to y will be the integrating factor, and we multiply this differential equation by the integrating factor. Okay, let's find the first. Now my minus nx over n is equal to, my is 3x squared plus 2x plus 3y squared minus nx is 2x over n is here, n is x squared plus y squared. Okay, on the top 2x cancel, 3x squared plus 3y squared, we can factor 3 out, that leaves x squared plus y squared over x squared plus y squared, and we can cancel, this is just 3, which is in fact a function of x alone, or we could say function of y alone, but that's not the case. So we are doing this my minus nx over n, so function of x alone. That means an integrating factor if it will be now mu as a function of x, because my minus nx over n, so function of x alone, mu x will be e raised to integral of this, which is 3 with respect to x. That's the integrating factor, which is e raised to antiderivative of 3 is 3x. Now we multiply this differential equation by e raised to 3x, and this will make this differential equation exact. Okay, so let me go back here. Now I want to multiply through by e raised to 3x. Multiply the differential equation by e raised to 3x. We get, so basically e raised to 3x outside, e raised to 3x, and we have 3x is square y plus 2xy plus y cubed plus, let's go back and see, so e raised to 3x outside dx plus same thing, e raised to 3x outside x square plus y square equals 0. Okay, and this should be exact. We can check. Now our m and n are updated, so this is m as a function of xy, and this is, so I forgot to write, should be dx, should be dy. Okay, this is n. Okay, and let's find m, partial derivative of m with respect to y, and partial derivative of n with respect to x, and they should be the same. So when we find the partial derivative with respect to y, e raised to 3x behaves like constant, so this survives here outside. Derivative of 3x square y with respect to y, 3x square behaves like constant, and derivative of y is 1 plus 2x behaves like constant, and derivative of y is 1 plus derivative of y cubed is 3y square. Now let's find the derivative of n, partial derivative of n with respect to x. So with respect to x, e3x is a function of x, so we have a product of two functions. That means we need to use product rule. So derivative of e raised to 3x is e raised to 3x times derivative of 3x3. Derivative of first factor times second plus first e raised to 3x times derivative of second factor. Second factor means x square plus y square. Derivative of x square we are doing with respect to x, so x square 2x plus derivative of y square is 0, you don't have to write, and my and nx should be the same. We can see by simplifying nx in both terms, e raised to 3x, e raised to 3x, we can factor e raised to 3x outside. Okay, then we can distribute 3x squared plus 3y squared, this is factor out, plus 2x. Okay, and we refer this to 1, or no, not now, we can, but we don't have to, and we just want to see if they are the same. Yes, these are same, so exact. That means what we found as an integrating factor, that was correct. Now we want to solve star. Since star is exact, since this differential equation is exact, then let me write, since the differential equation star is exact, by definition there exists a function f, function of xy, such that partial derivative of f with respect to x is m is a big thing, is e raised to 3x times 3x square y plus 2xy plus y cubed, and now this is 1 for future reference, and partial derivative of f with respect to y is n is in fact e raised to 3x times x squared plus y squared. Let's make this is 2. Okay, and we know the solution. The solution is given by the function equals a constant c. That's the solution. Okay, so all we have to do is find the value of f. We need to recover the function. To recover f from 1 or 2, we need to integrate 1 with respect to x, or integrate second with respect to y. Looks like equation 2 is simpler, so let's integrate 2. Integrate 2 with respect to y. Then integration of fy is just f now. Integration of this e raised to 3x x squared plus y squared with respect to y. So e raised to 3x bf's like constant we can pull outside. Now antiderivative of x squared is also constant, so x squared times 1, and antiderivative of 1 is just y, plus antiderivative of y squared is 1/3 y cubed, plus some constant of integration. Since x bf's like a constant, so we can have a function of x, so hx. Let's say this is 3. Okay, then the solution is f equals c. This function equals c, but we need to determine h. For that we make use of 1. In 1 we have fx, partial derivative of f with respect to x. So let's find the partial derivative of this function with respect to x. Then f x equals, so here is the function, we want to find the partial derivative with respect to x. So here's a product, so we need to use product rule, because this is a function of x and this is also a function of x. So using product rule, derivative of first factor is 3e3x times second plus first constant, derivative of second, derivative of x squared is 2x and y, plus this is y bf's like constant 0, plus derivative of h is a pure function of x, so regular derivative. Let's say this is 4. Now we compare fx 1 and 4 in this case. Compare 1 and 4 and get the value of 8. Okay, if we compare, okay, this is not simplified. Maybe we can simplify this and compare. So let me back up a little bit, okay, and rewrite this, simplify. How? So from these two terms, e raised to 3x, we can pull e raised to 3x all the way out, like in 1. Then 3, we need to multiply 3 inside, 3x squared y plus 3 times 1/3, 1 y cubed, just y cubed, plus e raised to 3x is factored out, what is left, 2xy, plus h prime x. Let's say this is 4. Now we compare 1 and 4, because we need to determine h. So everything looks same, y cube here, 3x squared y, 2xy, so h prime x should be 0, because we can always say plus 0. So comparing 1 and 4, to get this h prime is 0. That implies h is a constant function, because the derivative is 0 means the h is a constant function, and we can take 0, the simplest constant, so 0. Now we go back, and let me erase this, and find the function f. So h is 0, so from 3, okay, because this 3, this is the function f, and h is 0, so this function equals c is the solution. Thus the solution is the function equals constant, that is, here is the function where h is 0, or we can take any constant. That constant would be absorbed with this c. So e raised to 3x times x is square y plus 1/3 y cubed plus h is 0 equals c. Okay, this is the solution final.